Hello and welcome back to the classes by Mrs. Munisha Nagpal. We are back again with a new topic, simultaneous linear equations. Simultaneous linear equations will be requiring the concept that has been developed in the chapter linear equations in one variable. We have already learned an equation of the form ax plus b where a and b are real numbers and a not equal to 0 stands for a linear equation. That is, this is the general equation of a linear equation in one variable, because you can see only one variable over here. And for such kind of equations, we have a unique solution, one and only one solution, which is also called the root of the equation. Now, if I take an equation which looks like this, so I can see here a, b, c. Let us define this to be as real numbers, and a comma b, both of them are not equal to 0. So this is the general equation of a linear equation in two variables. Why? We can see two unknowns here, that is that is x and y. All right. So this is a linear equation in one variable, the general equation, and this is the general equation of a linear equation of two variables. All right. Now say for an example, let us take x plus y minus 7 equals to 0. Alright, by trial and error method, the different values of x and y, for which the right hand side will give you 0, because the left, I've told you already in the linear equations in one variable, we must always look for those values for which the left hand side and the right hand side becomes 0. That is, the equation is satisfied by the value of the unknown variable. Then such a value is called the solution. So here also there are two variables. That means there will be solutions for x and solution for y. That means there are roots here, one for x and one for y. So here suppose I take x as 3, y as 4. So 3 plus 4, 7. 7 minus 7 is 0. So RHS becomes 0. LHS is also 0. Alright. So that means 3 and 4 is one solution. 1 and 6. Here also 1 plus 6, 7, 7 minus 7, 0. So left hand side, right hand side, 0. We can take 6, 1, 0, 0, 4, 3, 0, 0. So we can see over here for several number of solutions. These were the whole numbers. There are also decimal numbers. So there will be unlimited or infinite number of solutions for such an equation. Okay. So a linear equation in two variables will give you infinite number of solutions. All right. Now coming to let us take a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0. Going by the defining the constants, that is a1, b1, c1 are all belonging to real numbers. a2, b2, c2, these also belong to real numbers, where a1, b1, a2, b2, none of them are equal to 0. So we can say that these are two equations of in two variables. Okay, two linear equations in two variables. Then such a system of equations is called simultaneous linear equation in two variables. It is called simultaneous linear equation in two variables. So in this topic, we shall learn how to solve such kind of linear equations, that is such a system of simultaneous linear equations. Remember, in our attempt to solve the linear equations of two variables, that is the simultaneous equations of two variables, we will get a value of x and a value of y. Whatever is the value, whatever is the variable used, if x and y is used in the two equations, then one value for x and one value for y we will get, which will satisfy both the given equations. Say for an example, x plus y equals to 7. Let us take this equation, and x minus y equals to say 3. Okay, so you tell me for what value of x and y both the equations will be satisfied. Let us check for the first equation, x, y, LHS, RHS. Let us check. Okay. 1, 7 this side, 7 this side. So 1 and 6 we can take. So 1 plus 6, 7 and 7. 6 and 1 also we can take. Alright. Other values. What are the other values that you can get? Say 2 and 5 and 5 and 2. So 2 and 5, 7. And so the right hand side also 7. 5 and 2, 7. 7. Now you see here, if we put the value 5 and 2 here, 5 minus 2, that is equal to 3. 3, 3 same. So this value of x as 5 and y as 2, and here also x as 5 and y as 2. So x as 5 and y is 2. This satisfies both the equation. So this is the solution of the system of simultaneous equation given to you. So when you solve simultaneous equations of two variables, when two equations are given, you will get one single value for x and one single value for y. Now in this chapter, our objective will be to find out these roots of the equation, that is of the given unknown variables, to find the solutions of the unknown variables. Now for doing this, we will be using three kinds of methods. First method is the substitution method. Second, the elimination method. Third, cross multiplication method. For a system of simultaneous linear equations, you can use any one of the three methods to solve the equations. Irrespective of the method that you are using, you will get the same answer. Okay, using the three different methods, you will get the same answer for the given system of equations. Okay, now all the three methods will be discussed. I will explain all the three methods. Now it's entirely up to you which method you will prefer for solving your equation. Also, which method, particularly if you are asked in the examination about a method being mentioned in the question paper, then you have to go by that method. If no such criteria is mentioned in the question paper about which method to go with, you can use the method as per your wish. Okay, but you will practice all the three methods, because you never know what will come up in the examination. You might be given the name of a particular method. Teachers might ask you to solve the equations given that you have to solve using so and so method. So you have to go by that. Even if you do some other method and fetch the same answer, you will not be allotted any marks for that, because you are not following the question. So you have to follow the question. Alright. So we are going to start with the first method, that is the substitution method. Alright. Now let us take a equation. Say for an example, the previous sum only I will do. The one which I had solved using the trial and error method. X plus y equals to 7 and x minus y equals to 3. This was my question which I had done previously, shown you with the trial and error method. Now we will be using the substitution method. We are going first by this method. The same sum I will solve using all the three methods. Alright. Now the first method, substitution. Now the word substitution, what does it mean? That is placing someone in the position of the other. Alright, this is the meaning of a substitution. So, using any one of the two given equations, you will make a variable as a subject of the other, or make a variable as a formula of the other. Like for an example, see here, I will use this equation. So this is equation number 1, equation number 2. So using 2, I will be making x is equal to 3 plus y. So here x is framed in terms of y. We are finding we are making x as the subject in terms of y. Alright, now using second one, I have done this. Now let us name this as 4. Now this value of x that I have got in terms of y, I will place this in the first equation. Alright, that is, now here in place of, what was the equation here? You will write here, putting 4 in 1. So you are putting equation number 4 in 1. Make sure whichever equation you are using to make a subject, after making the subject, you will place it in the other equation. Don't use the same equation, the other one. Either you can make a subject using the first one and then place it in the second one, or make subject using second one and place it in the first one. It's not that always x has to be made the subject. You can also make y as the subject, following the same pattern. Using one equation, make a subject, place it in the other equation. This you have to keep in mind. So putting 4 in 1. So what is the 4? 4 is x. So in place of x, we will put 3 plus y equals to 7. Now what you can see over here, we can see that there is no x in this new equation that has been framed here. So it is now a linear equation in one variable. So we have reduced the linear equation of two variable into a linear equation of one variable. Alright, it is now transformed because we can see only y over here. So 2y equals to 7 minus 3. Y equals to 4 by 2, that is 2. So y's value is 2. Now you have got y over here already. So putting y equals to 2 in this one, because we had made x as the subject, you can put it here, you can put it here, because you can put it here as well. So any one of the three, see this and this is same. From here only we got this. From second we got the fourth one. This should be the third one. This is 1, 2, 3. Third equation we can write over here. Numbering third. Placing 3 in 1. Yes. So now once you get the value of y, you can put it in 1, you can put it in 2, or you can put it in 3. See, 2 and 3 are from the same equation. Alright. So in any one of these you can put it. So putting y is equal to 2 in, better put in this because it's already ready made for you, because we are finding x only. So putting in 3. So x is equal to y, 3 plus y. So 3 plus y means x is equal to 3 plus 2, that is x is equal to 5. And if you remember in the previous example that I had done using your trial and error method, there we had got x as 5, y as 2. So x as 5 and y as 2, you can check it also. 5 plus 2 equals to 7. So both sides are 7. 5 minus 3 equals to 5 minus 3, 5 minus 2, x minus y. 5 minus 2 equals to 3. So satisfied. So the solution is therefore x equals to 5 and y equals to 2. This is the solution for the given system of equations. I repeat once again the process. Given two equations, you will make any one of the variables as a subject of the other. That means you are expressing one of the variables. You can do it using y also. I will show that also. So you can make either x or y, express that in terms of the other. So here in this one I have expressed x in terms of y. We can also express y in terms of x using any one of the two. Now whichever has been used to express this, after being expressed, this has to be placed in the other equation. Okay, the one which was not used, to place it over there. Alright, once you place it over there, you will see that the resulting equation that you are getting right now has no two variables. It has only one variable. That means you have reduced your equation from two variables to single variable. And we have all now become pro in linear equations of one variable. We have done a lot many class based on that. So we have now reduced it to a linear equation in one variable and then solved the unknown. What was the unknown over there? Y. Here, according to this sum, our unknown was y. So once we get the y, now place back the value of y in this one. That is the one that is formed by you. I always prefer placing it here because it's already a ready-made one. Okay, so place it over here, the one that is made by you, the equation that you had made while doing the substitute, while making the formula or making the subject. Place it over here because x has to be found out. So putting the value of y, we got the value of x. So this x and this y will satisfy the two equations. Always cross check whether it is satisfying or not to be on the safe side. In the rough column you can do that. So put the value of x and put the value of y in both the equations and check whether you are getting a right solution or not. Means verify the equation, verify the solution. Alright. Once it is verified, then you are confirmed that your solution is correct. So you'll be in a safe state. Alright. So here, as per this equation, we got x as 5 and y as 2. Solved. Now the same thing if I do, as I told you, using y. And I will use the other equation. Let us see. I will use this. I could have done using this also, but since I have done already x with this, I will do y with this. Okay. So y equals to 7 minus x. What did you do? This is using 1. So let us name this as equation number. This is equation number 3. Now because I have used first equation, this substitution has to be made in the second equation. Alright. So using 3 in 2. 3 I will use in 2. So x as it is, in place of y you will put 7 minus x. Why did I put in the bracket? Because there's a minus sign here. So to be careful about the sign, this is 3. So x minus 7 plus 2 equals to 3. So this is x, sorry. So x plus x is 2x is equal to 3 plus 7, that is 10. So x equals to 5. So we have got x is equal to 5. So putting or substituting, whatever you might use the term, putting x equals to 5 in 3. So y is equal to 7 minus x. This was the thing. So 7 minus 5. So y equals to 2. So we got x as 5, y as 2. See, any way you do, you are getting the answer. Alright. So this is clear, I suppose. Let us do another sum based on this, so that our idea becomes quite clear with this. Let us take x plus y equals to 7 and 3x minus 2y equals to 11. I have taken two equations, x plus y equal to 7 and 3x minus 2y equals to 11. So number the equations. Numbering the equation will help you a lot. Okay, now what you want to substitute? Always go for the simple equation where substitution becomes easier. Okay, so I will use 1. So using 1, say x is equal to 7 minus y. Why I did not use 2 over here? I could have. But here you see, if I would have used the second equation, what would have been the chances of making mistakes are, if I would have done 3x is equal to 11 plus 2y, x is equal to 11 plus 2y by 3. This by 3. Some of you all will make mistake. Out of 10 children, 3 will make mistake. If I am taking the least count, 3 will make mistake. So I always prefer my students to use the equation which has less these kind of fractions and all. Alright, to be on the safe side. Alright. Hard work is equal to smart work as well. So if you are using hard work, please remember to put some amount of smart work also. Both are equally important. Only doing hard work will not do, or only doing smart work will not do. Both have to play equally in your papers or equally when you learn maths. So x is equal to 7 minus y. Now this is equation number 3. Now putting or substituting, putting 3 in. Now because I used 1, I will now put it in 2. Remember, don't make mistake in putting in the same equation. Then you will get back your original equation. Okay. No, the equation which you are using for the substitution or making the formula, not that. The other one in this in which the newly framed equation is to be set in. So putting x is equal to 3 in 2. Alright. So 3, well, this was 3 into, in place of x we will write 7 minus y minus 2y equals to 11. So 21 minus 3y minus 5y equals to 11. Now you can see that we have reduced the equation to a linear equation in one variable. You can see only we have y in the equation. Alright, now minus 8y equals to 11 minus 21. So minus 8y, okay, 1 second. This is 2y. This is 5. Yes. So this is minus 10. So y equals to minus 10 by minus 5 or y equals to 2. So we have got the value of y as 2. Now putting the y as 2 in 3 using y equals to 2 in 3. So x is equal to 7 minus y. So x is equal to 7 minus 2. That is x equals to 5. So see, put it in place of x 5. 5 plus 2, 7. Equation 1 satisfied. Second one, 3 into 5 minus 2 into 2. What is the result? 15 minus 4, which is 11. That is the RHS. That means we are getting a correct solution for the given system of simultaneous linear equations. That means this is the answer. Therefore, x equals to 5, y equals to 2. And in the previous sum also we got the same answer only, x is 5 and y is 2. So, for this system of equations, we have got x is equal to 5 and y equals to 2. So, I think this is clear. This method is clear to everybody. Now, going to the second method, that is the elimination method. Now, as the name itself tells you, elimination means removing. So, there is something which is removing or being removed in this process. Now, what is this process? In this process, you will be either using, the first thing that you will be doing is, first step here is making equal numerical coefficient of either x or y. Here x or y I am using because you might get some other variables also. I am using x and y over here, but this is for all variables that can be used over in an equation. So first thing is making the equal numerical coefficients of x or y, either one. You will make equal numerical coefficients. Second is use addition or subtraction. And then third one is solve. Whatever is the resulting result, whatever you are getting after this step, to solve. Now 3 steps have been told over here. Now what is this 3 steps? Check. We will go to the equation that we have been using. X plus y equals to 7 and x minus y equals to 3. I think this was the equation that we have been using. Okay. So here making the coefficients of x or y equal. So here in this case you see x also has 1, y, here x also has 1, here y has 1, here y has numerical coefficient minus 1. Okay, here nothing. Now what you will do is you will either subtract the equations or you will add the equations as per your choice. So if I add the equations over here, the 2 equations if I add, so addition if I do, see y and y becomes 0, plus y minus y 0. So x plus x is 2x, 7 plus 3 is 10. So we have now reduced this to a linear equation in one variable. So x is equal to 5. Okay. Now the equations were x plus y equals to 7 and x minus y equals to 3. Now in any one of the 2 equations you put the value of x. So suppose if I take this one, 5 plus y equals to 7. So y is equal to 7 minus 5. So y equals to 2. So we have got the answer. X is 5, y is 2. Alright. Clear? Another example. To make it more clear, let us take the second one that we were using, x plus y equals to 7 and 3x minus 2y equals to 11. So here you see, for x we have 1, for y we have 1, for x we have 3 and y we have minus 2. So what you can do is either make this x and this x having the same number in front of them, or make this y and this y having the same number in front of them. So since this equation already has 3 in front of x, so you can either bring a 3 here or bring a 2 over here. Together you cannot bring 3 and 2 together, either 3 or 2. Means either of the numerical coefficients has to be made same. So what you can do is, if changes has to be done over here, here no changes. Okay, here I will do the changes. So x plus y is equal to 7. This whole equation I will multiply with 2. I will multiply with 2, not minus 2, 2. So if I multiply with 2, this becomes 2x plus 2y equals to 7. What calculation will go behind your mind when you are doing this? The calculation is that what number I should multiply the equation with, the equation with, so that on addition or subtraction one of the variables get removed. So if I multiply a 2 here and add them, so 2y and minus 2y will become 0. If I would have multiplied a 3, then this would have become 3x, 3y and 21. Okay. But in that case, I wouldn't have added the equation, I would have subtracted the equation. Why? Because plus 3x and plus 3x, if I add, there is no removal or there is no elimination of the x. Elimination will take place only if I subtract the equation. But for x and y, for the y, if I make the y same, the numerical coefficients of the y same, then by addition of the two equations, the y will be removed or eliminated. So the new equation that I have formed is 2x plus 2y equals to 7. Now this was the 3x minus 2y equals to 11. The new equation that I have formed, 2x plus 2y equals to 7. Now you add the two equations. Plus 2y minus 2y, 0. 2y plus 3y, 5y equals to, this is your 14. This is your 25. Okay. So y equals to 25 by 5, that is 5. Now put the value of 5 in any one of the two given equations, the original ones. So if I put x plus y equals to 7, if I take this equation, so x plus 5 equals to 7. In place of y, I have put the value of y. So x is equal to 7 minus 5, or x equals to 2. So x as 5 and y it is x is 2, y equals to 5. Okay. So we have got the answer for it, that is x is 5 and y is x is 5. X plus y equals to 7. So y equals to 7 minus x, that is y equals to 7 minus 5. So y equals to 2. That means your answer, x equals to 5 and y equals to 2. So if you, we have already checked in the previous method only that 5 and 2 satisfy the given equation, because I have been using the same equation. So using the same equation, we can see that the solution is satisfying both the equations. So for the value x is equal to 5 and y equals to 2, the equation is being satisfied. Now this is with addition. We will do one with subtraction. Let us do one with subtraction. Say for an example, (4x minus 3y equals to 8) and x minus 2y equals to minus 3. Alright. So here what you can see, to make the x having the same number in front of them, what we can do, I will multiply the second equation with a 4. That way, and then subtract it. Why? Because both of them are having plus signs. If I add the x will not get removed. So you have to subtract it. And if I want to remove the or eliminate the y, then in that case what are we going to do? We have to make both of them having the same number in front of them, but this has 3 and this has 2. So with what number are you going to multiply? How will you decide that? So take the, for such a case, for this you can easily understand 4 we will multiply, but for y you take the LCM of the two coefficients, 3 and 2. What is it? 6. So to make it 6, make it 6. Okay, I'll show elimination of x and elimination of y. So first I will do elimination of y. So 4x minus 3y equals to 8. This you multiply with 2 because we want to make this 6. And x minus 2y equals to minus 3, multiply with 3. So that this becomes minus 6. So now this resulting to 8x minus 6y equals to 16. This becomes 3x minus 6y equals to minus 9. Now what you will do? Addition or subtraction? See, if you do addition, none of the variables are reduced. So because both of them are having, this is not getting reduced by addition or subtraction. But this can be reduced only by subtraction, because if you add, we will get minus 12y. We have to subtract. So subtract means all the signs will get changed. Okay, this becomes plus. So 8x minus 3x is 5x. Plus 6y minus 6y becomes 0. So this is plus 6y now and this is minus 6y. So 0. And it is 16 minus 9. That is your 7. Oh, this is plus, sorry. Minus to plus. That becomes 25. Alright. So x is equal to 25 by 5. That is your 5. So we have got x as 5. Now put it in any one of the original equations. Say I'll put it here. X minus 2y equals to minus 3. In this I will put x as 5 minus 2y equals to minus 3. That means minus 2y equals to minus 3 minus 5. So minus 2y equals to minus 8. Or y equals to minus 8 by minus 2. That is 4. So what is the answer? X equals to 5. Y equals to 4. You can put the values of x and y in the two original equations and see that it is the solution that will satisfy both the equation. So for this our answer is, or the solution of x is x equals to 5 and y equals to 4. Alright. This was done for eliminating the y. Now let us see if we can do with elimination of x and get the same answer. So LCM when you will do, when you see both of them are having factors, LCM you take out. I mean factors means when both of them are having different kinds of numbers, with what number you will have to multiply. If that is in your head or that is in your mind, take the LCM. Once you take the LCM, now you will be easily be able to find out by what number the two equations have to be multiplied with. Now for this, you can also think 4 and 1, LCM is. So when you can multiply this with 4, so this equation becomes 4x minus 8y equals to minus 12. So 4x minus 3y equals to 8, and this is 4x minus 8y equals to minus 12. Now what you will do? If you do addition, this is not getting eliminated. The x is not being eliminated. The one that whose numerical coefficients you are making equal, that has to be eliminated. So think which one you will use, which operation, addition or subtraction. If you use addition over here, 4x plus 4x, 8x, not getting eliminated. So use subtraction. Subtraction, excuse me, subtraction. So this sign becomes minus, this sign becomes plus, and this sign becomes plus. Okay. So plus 4x and minus 4x, 0. That is gone. So 8y minus 3y is 5y, and 12 plus 8 is 20. So y equals to 20 by 5, or y equals to 4. So you can see one thing, in the substitution method as well as in the elimination method, we are reducing it to a linear equation in one variable. The two variables are reduced to linear equations in one variable, and then we are solving it out. Okay, so y is equal to 4. Now use any one of the two equations. So x minus 2y equals to minus 3. So x is equal to what? Minus 3 plus 2y, isn't it? So x is equal to, now putting the value, minus 3 plus 2 into 4, 8. It is minus 3 plus 8 is equal to plus 5. So your answer, x equal to 5, y equal to 4. This was the solution we got initially when we eliminated the y. Okay, there also we got the previous one. So here we eliminated the x, the previous one we eliminated the y. Alright, so here also we got the same answer, that is x is equal to 5 and y equals to 4. Alright, I hope it is clear now, both the equations. Given you time to think about it. Alright, now the two methods, that is a substitution method and elimination method, have been discussed today. Sums also have been done based on this. So as you get a idea and develop a concept on this, take hold of your textbook, get equations and solve it using these two methods. The third method ma'am has not taught today. She will teach in the next video. For you to take time and ponder upon these two and be swift and very fast with these two methods. Okay? Most of the cases I have seen children using second method. Most of the cases. Alright? But there are exceptions who use the other methods also. But maximum times I have seen children using second method. But I will always prefer you to practice the three methods equally. Give all the three methods equal importance. Alright? So that you are thorough with all the method. You are perfect in your own way. Okay? So you don't give any preferences. You do all the three methods. So today's class comes to an end over here. We have done two methods. The third method in the next video I will be coming up with. Till then, make sure by the time I come up with the third method, you should be thorough with the first two methods. Take up sums from your textbook, from whichever source you can. Take up sums, solve the sums using both the methods. Same sum using both the methods. So you will be very comfortable with the sums when you do like that. Okay, that is a way of practice. Now, if you like the class, please do like the channel. Comment your problems, your doubts. As I told you always, I would be very happy to attend them. Thirdly, subscribe the channel if you haven't subscribed yet. Till then, bye. And also remember, to do this topic, you have to go through linear equations in one variable. If you have not yet gone through, the links of those videos have been mentioned in the description box. Kindly go through them. It's a earnest request so that you are thorough with the entire system of equations in one variable and two variables. Okay, meet you in the next class. Till then, goodbye.